Namaste to all my dear students. How are you? Today I am giving you very interesting lecture about the balancing of redox reaction by ion electron exchange method. I have already told you, I have already give you lecture about the balancing of chemical equation by what to see oxidation number method. So today I am giving you very interesting. So what you see balancing of redox reaction by ion electron method. So that is very important for knowledge as well as what to see examination view of point. For this we know some important rules. So first rule according to this, first rule is at first oxidizing and reducing agent are written in ionic form. That is very important point. Suppose we take very simple example, copper plus dilute nitric acid. So what to get? Cupric nitrate plus H2O plus nitric oxide, that is nitric oxide, that is cupric nitrate. Yes. So according to first rule, we have to convert all these in ionic state. Suppose copper plus, also you have to know the oxidation number of copper is 0, nitrogen is plus 5, copper plus 2, and what you see in this case nitrogen has 2. So what we have? 2 over there. Nitrogen has what you see? Plus 2. Plus 2. Yes. So at first we have to convert into what you see ionic state. So what is copper? Nitric acid after ionization, what we get? S plus nitrate, copper, that is the arrow. So copper plus what we see nitrate. Yes. So how many nitrate? 2 nitrates. You can write 2 nitrate. So H2O, it does not ionize, NO also does not ionize. Yes. So at first we have to convert into what to say? Ionic state. That's first rule. Second rule is like this. According to second rule, divide the chemical equation into two half. Yeah. Eliminating ions which are neither oxidized or oxidized or reduced. Yes. So in this case, copper plus S plus nitrate. So what we have? Copper plus 2 nitrate plus what we say? S2O plus NO. Yes. So oxidation number copper is what C plus nitrate plus 5. Copper 2 already 2 has, it has what we see? Plus 2. Yes. So what we see over here? So oxidation number of copper increases from 0 to 2. So what we have over here? Oxidation, and that is what we say? Reduction. Reduction, yes. So copper in this case is reductant. Why? Because it brings about what's nitric acid as a whole is what we say? Oxidant. Always we have clear concept about the reductant and oxidant. If we have clear what is the concept of reductant and oxidant, we have never problem to balance the chemical equation by redox, what is it? What is the ion electron method. Yes. So divide. So in this case 0 to plus 2, in this case plus 5 to plus 2. So first one is what to say? Copper oxidation half, better to say A is oxidation half. Oxidation half always increase in oxidation number. Yes. B is reduction half. So what to say? Decrease in oxidation number. So in this case 0 to plus 2. So what do we have? Copper 0 to what you see? Copper plus. Suppose that is the chemical equation 1. Second one is what you see? Nitrate to what you see? NO. So in this case what you see? Nitrate, nitrogen has plus 5. Nitric oxide, what we have? Plus 2. That is the nitric oxide. That is nitric. Suppose that is the chemical equation 2. Yes. So that is the second rule. Now, according to third rule, a third one. So balance oxidation and reduction half. Reduction half at first atom wise. In this case, so two medium over here. So one is suppose in acidic medium. In acidic medium, always keep in mind, if sort of hydrogen atom, what we have to add? S plus ion. Yes. If sort of oxygen atom, so what we have to add? S2O for one oxygen atom, and other side add what to say? 2s plus in acidic medium, B in neutral or alkaline medium, if sort of hydrogen atom add water and add S2 in another site. Likewise, if sort of oxygen atom add 2 OH ions for 1 oxygen and add S2O in another sites. Yes, always we have to keep these points. Now, fourth one is balance both oxidation and reduction by charge wise. Charge wise must be neutral. Charge wise must be neutral. Yes, we are showing by example. So, what we see A, copper oxidation half, what do you see, copper 0 to what you see, copper plus 2. Yes. So, if I have to balance at first atom wise, so how many copper? 1 copper, 1 copper. So, already balanced. Yes. Now, we have to balance this one by charge wise. Yes. This was what we have, copper plus how many positive charge? 2 positive charge. So, you have to make neutrals. What we have to do? We have to add 2 electrons. When we add 2 electrons, it becomes cancel, neutral we can say. So, suppose that is chemical equation 1. B, reduction half. So, reduction of what we have? What is the nitrate? Nitrate to nitric oxide. Yes. So, at first we have to see the central atom, nitrogen balance, nitrogen is balanced. But in this case 3 oxygen, but in this case 1 oxygen. So, what we have? 2 oxygen is deficient. So, what we have to add over? 2s2. And next side we have to add how much? For 1 hydrogen 2s2. What you see? 2s2, it means 4s plus. So, we have to see whether it is balanced by atom wise or no. So, what do you see? Nitrogen 1, oxygen 3, 2 and 1, 3. How many hydrogen? 4 hydrogen, 4 hydrogen, yes. So, that is atom wise balance for oxygen atom, you can say, for oxygen atom. Now, we have to balance by charge wise. So, what you see? 4s plus 1. So, when what you see, 1 proton is displaced, what is neutralized. So, how many? 3 electrons, 4s plus nitrate, what you see, NO 2s2. Why we have to add 3 electron over here? So in this case 4 proton, 1 electron. When add S, what we have? 3 proton. And to make 3 proton neutral, what we have to add? 3 electrons. Yes. So suppose that is the chemical equation 2. Yes. So that is atom wise and chemical wise, what is the balance. Now fifth rule. So cancel electron by multiplying with suitable number and adding and subtracting all reactants and products to get what we see net reaction. So what we see in first one, 2 electron over here. In this case 3 electrons. We have to cancel. So what we have to do? We have to multiply by 3. Why? 2 3 are 6. This second one we have to multiply by 2. Why? 3 2 are 6. So at first we have to cancel the electron. Now copper already take 4S plus nitrate NO 2S2. Yes. So in left hand side, look at left hand side, copper multiply by 3. So what to get? 3 copper. Yes. Left hand side over here, 4S plus multiply by 2. So how to get? 8 plus nitrate multiply by 2. What to get? 2 nitrate. Yes. In left hand side. Now right hand side multiply by 3. What to get? Plus copper 3 plus. What we see? In right hand side NO multiply by 2. How much? 2 NO. And what is S2O multiply by 2? What you get? 4S2. Yes. So that is what you see net reaction. That is known as net reactions. Again, check over here. Copper multiply by 3, correct. 4S plus multiply by 2, 8S plus, correct. Nitrate multiply by 2, 2 nitrate in left hand side. Right hand side, what we have? 3 copper ion plus NO multiply by 2. So how much get? 2 NO plus what is it? 4S2. 2 2 is 4. Yes, that is charge wise and atom wise balance. Now we have to, according to sixth rule, to get original equation, what is it? Balance by what is it? Inspection, or better to say heat and trial method. You know, always we need. So what you see? So to get original equation, what we have? Balance by inspection. So what we have? 3 copper. So what we have? 3 copper. H, 8 H, what we have? 8 molecule of nitric acid. Yes. In right hand side 3 copper. So what we have? Copper nitrate plus 2NO plus 4AS2. So it is balanced chemical equation. It is balance chemical equation. Yes. So for balancing by redox reaction by ion electron exchange method, we have to follow 6 rules. So I think you have clear what the 6 rules. Now another example. Yes. Another example. Suppose second one, Zn plus very dilute nitric acid, what we get? Zinc nitrate, ammonium nitrate plus what we see? Nitrate plus what we see was S2. Now we have to balance by ion electrons. Zn 0, you know, nitrogen has +5, zinc has +2. How? Because 2 over here. Nitrate 1 valency, zinc has 2 valency. Ammonium, so what we have? In this case, ammonium. So ionized, what we get? Ammonium has -3, nitrogen has +5. Yes. So according to first rule, we have to convert into ionic state. Yes. So what we have? Zn plus nitrate plus ammonium plus nitrate plus S2. That's first rule. So we have to choose only those ions which are oxidized and reduced. So in this case, zinc 0 to +2. So that is oxidation half. That is oxidation half means increase in oxidation number 0 to +2 over here. So what you get? 0 to Zn plus. Yes. Suppose that is the chemical equation 1. So at first we have to balance by atom wise. 1 Zn already balanced. Yes, atom wise balance. Now we have to balance by charge wise. So how many proton over here? 2. So what we have to do? We have to add 2 electron. Why? To neutral this one. So that is the atom wise as well as charge wise balance. Likewise, next one is what we say? What is the reduction half? What do you say? Reduction half. So what we have? Nitrate to ammonium. We cannot write nitrate to nitrate, so many nitrate over there. So only we have to choose those ions which have what change in oxidation number and reduction number. Yes. So in this case, nitrate has +5. In this case, what you see? -3. Yes. So we have at first balance by atom wise. So how many nitrogen in left hand side? 1. Right hand side also what you see? 1 nitrogen. At first we have to see the central atom. Now oxygen. How many oxygen over here? 3. In this case, no oxygen. So for 1 oxygen, 1 S2, 3 oxygen, what we had? 3 S2. Yes. Left side, what we had? 3 to the 6 S plus. Yes. So it is for oxygen atom. We have to balance oxygen atom. Yes. Now we have to see the hydrogen over here 4, but in this case no hydrogen. So what we have to do? For 1 hydrogen, what you see? 1, how many? 4. So what we can write? 4S plus 6S plus nitrates. What do we have? Ammonium plus what you say? 3S2. Yes. So we have to see whether it is balanced or not. So 4H, 4, 6, 10H. In this case 4H. In this case 6, 4 and 6. How much? 4 and 6, 10. How many oxygen over here? 3 oxygen. In this case 3 oxygen. 1 nitrogen, 1 nitrogen. Atom wise as well as what you see charge wise, both what you see it is balanced. Suppose that is the second chemical equation. Now in this case 2 electron. Now we have to balance charge wise. So how many? So better to write over here. So what we say according to first Zn plus what we say Zn plus 2 electron, that is chemical equation 1. 4 and 6 how much? 10H plus what we say nitrate in left hand side, right hand side what we have ammonium plus what we say 3H2. Yes, that is the second. So what's 10H plus over here, 1 plus what you see 10 minus 1 how much? 9, and 9 minus what you see 1, so how much? 8 electrons. It must be what is neutral. 10H plus nitrate, what do you get? Ammonium plus what you see 3H2, that is the second. Now always see, always electron must be what you see anti to each other. We have to cancel this one. So here was always they are anti to each other. So how many electrons over here? 2. In this case 8 electrons. What we have to do? We have to multiply by 4. Why? To cancel this one. Yes. Then what we have? Look at over here. So what do you see? We have multiplied by 4. So first we have to cancel the electron, then adding and subtracting all to get the net reaction. So what we have? So 4 multiplied by Zn, so what we had? 4Zn plus left hand side 10H plus nitrate left hand side. Now right hand side Zn multiplied by 4, so how much? 4Zn plus what you see? Right hand side how much? NH4 plus 3H2O. Yes, that is the net reaction. That is known as net reaction. Yes. So what is it? 4Zn 10H plus. Now according to 6th rule, to get original reaction, we have, so what you see? Zn 4Zn plus 10 nitric acid. Yes, left hand side, right hand side is 4. What do you say? 4 Zn nitrate plus ammonium nitrate plus 3H2. That is balanced chemical equation. That is balanced chemical equation. Yes. So for this we know 6 rules. If we know 6 rules, we have never problem to balance any chemical equation. Yes. Now next example. Next example 3. So suppose magnet plus sulfide, all H plus, also in all cases nitric acid, so acidic medium. So this one what we see, Mn plus what we say, H2O plus sulfur. So what we have? Yes. So in this case, Mn has what you see, how much? Oxidation number. In this case, you know, plus 7. In this case, plus 2. In this minus 2. In this case, what you see, 0. So what we have? That is what we say, plus 7 to plus 2. So what we have? Reduction. Reduction. In this case, minus 2 to what we see? So that is oxidation. Oxidation always increase in oxidation number. Yes. So what we have? So what you see? A, divide the chemical equation into top form already in ionic form. So we have not changed into the ionic state. So MnO4 in this case oxidation half what we have minus sulfide to sulfur. Yes. So at first we have to balance by atom wise or one sulfur, no problem. But in this, when we balance by charge wise neutral, so in this case 2 electron, in this case no any. So what we have? We have to add 2 electrons. So that is the chemical equation 1. Yes. So atom wise and charge wise both what you see? Balance over here. Next one is reduction half. Reduction half. What we have? That is known as permanganate ion. What you see? Mn2 plus. Yes. So what you see? At first we have to do set the what is the central atom? 1 Mn, no problem. 4 oxygens. So what we have to? 4 is to balance oxygen atom according to rule. Yes. So what we have oxygen? 4H2O. In this case, what? How much we have to add? 8 plus. So we have to see whether it is balanced by atom wise or not. 8H. In this case, 4 to the 8, right? 1 Mn, 4 oxygen. Atom wise already balanced. Now we have to balance by charge wise. So how much? So in this case, 8 plus 1, add 1 electron. So how much? 7. Yes, in this case, 2 proton in the right hand side. So when you substitute 2, so what we have to add over here? 5 electron. 8 H plus MnO4. So what you see? Mn plus 4H2. Yes. So that is atom as well as what you see? Charge wise balance. Again you see 8H plus, when you add 1 electron, what we have? 7 plus. In this case 2 plus, when you take in left hand side, so what you see? 5 proton, and we have to make 5 proton neutral. What we have to add? 5 electron. Yes. So no, both are reaction. What now we have to cancel this electron. So in this case we have to multiply by 5. In this case we have to multiply by 2. Why? To cancel this one. Yes. 2 5s are 10. 2 5s are 10. Yes. So what do we have? Yes, so look at A. What we say? One. So we have to balance. We have to say multiply by 5. We have to multiply by whole chemical equation by 5. And the second one is what you see? 5 electron plus 8 S plus permanganate in left hand side. Right hand side is Mn2 positive charge, 4H2. We have to multiply by 2. Yes. So now so what you see? Net reaction over here? How much we have? In this case, we have to multiply by 5. Yes, that is the chemical equation 1. That is the chemical equation 2. Yes. So sulfur already we have to multiply by 5. So what you get? 5 sulfur. Yes. Left hand side, inside keep 5 to the 10 electron. Yes. 8 to the 16 S plus. MnO multiply by 2. What you get? Minus in left hand side. Right hand side multiply by 5. 5 yes 0 means no charge over here. So what you see? That is cancel out. And what to say? Mn multiply by 2. 4H2 what you get? 8H2. That is the net reaction. So that is what you see? Net reaction. Now in this case already what you see in ionic state, so we have to not convert into the original position. Yes, again look at over here, 5 yes sulfide, yes, 10 what you say, 10 not 10 electron, already cancel over here. So 16 multiply by 2, 16 yes plus 2 multiply by 2, 2 MnO4 in left hand side, and what you get 2 MnO4, and what you see 5 yes plus 2 Mn yes 2 Mn, what you see 8 is 4 to 8. So we can write what we have, MnO4 how much, 2 sulfide 5, what you see 16 H. So in this case Mn plus H2O, 2 Mn plus what you see 8 H2O, 5 S, and left hand side how much, H plus 2 MnO4 minus what is 16 H plus 5 sulfides, what we have, Mn plus 8 H2O plus 5 S. That is balance, net reaction you can say. That is that reaction. Yes. So I think you have clear. Next example is like this. I2 plus nitrate, iodine plus nitrate. So condition is S plus. S plus means acidic condition. So what we have, IO3, that is iodate, plus what we say, nitrogen dioxide plus H2O. Yes. So in this case 0, in this case plus 5, in this case plus 5 plus 4. So what you see, I2 is in this case is 0 to what you see, plus 5. So that is oxidant. So what you see, a oxidation half, so already in converted into what's ionic states, not necessary. So I2 iodate. Yes. So at first we have to balance central metal. How many iodine? 2, in this case 1. We have to multiply by 2. So now how many electron? 2 electrons. So we have to make the neutral. So what we have to add? 2 electron over here, 2 electron in the right hand side. That is atom wise as well as charge wise balance. Now reduction half. Reduction half, what we have? Nitrate to what you see, nitrogen dioxide. At first we have to balance central atom, 1 nitrogen, 1 nitrogen, 3 oxygen, 2 oxygens, 1 oxygen deficient. So what we can write? H2O. Yes, in this case 2S plus. Yes, that is atom wise balance. Now we have to balance by charge wise, 2S plus 1 nitrate. What do we have? 1 electron plus 2S plus nitrates. What do we have? NO2 plus S2. That is the charge wise and what you see, atom wise balance. Yes. So yes, so now what you see, first question, how many electron? 2 electron. In this case 1 electron. So what we have to do? We have to 2 electron, 1 electron over here. Oh, 2 electron iodine. Oh sorry, 2 electron iodine. We have to balance this one. I2, 2 I2, correct. So in this case, how many oxygen? 6. So what we have to do? 6H2O. Yes. In this case, what we have? 12 H plus. As a rule, what is 6H2O? 12 H. We have to see whether it is balanced or not. 6 2s are 12, 2 iodine, oxygen 3, oxygen 6. So already balanced. Yes. So we have to balance charge wise. How much? So 12 when added 2 electrons, how much? 10 protons. So what we have to do? We have to add 10. 10. Why? Because 10, yes, plus. When add 2 electron, how much? 10. So we have to 10 protons. We have to balance 10 proton. We have to add 10 electron over here. Yes. So now we have to multiply this one by 10. Yes. One not necessary. So what we have? A in left hand side 6H2O plus I2. Here look at over here 10 electron, that is the cancel out. Yes. So 2H 10 to the 20. H plus nitrate multiply by 10. How much? 10 nitrate in left hand side. Now right hand side look at over here 2 iodate. Yes. 2 iodate plus what's your 12 H plus NO2 multiply by 10. How much? 10 NO2 plus H2O multiply by 10. How much? 10 H2. Yes. So now we see. So in this case 6H2O, 10 H2O. So subtract this one. Sometimes adding, sometimes subtracting over here. So what you see 6H2O and what you see 10H2. So what you see I2 20H plus 12H. So what you see 8 remaining 20 and when subtract 12 how much 8H plus what you see 10 nitrate. Right hand side 2 iodate plus 12 was already balanced. What you see substrate over here 10 NO2 plus 10 H2O. In this case 6H2 when substrate. So how much we get? What to say 10 minus 6 how much? 4H2. That is net reaction. That is net reaction. Balance. You can say balance. Yes. So very easy if you know the rule. So this you have to know the rule. Last one for today 5. So all are the acidic condition. Now to what you see bromine plus potassium hydroxide. So that is the OH means basic condition. Yes. So what you get KBr plus KBrO3, that is known as potassium bromate plus what you see water. Yes. KBr potassium bromide. Yes. So again Br2 0. In this case minus 1. In this case what you see plus 5. So 3 2 is 6. When you subtract 1, so how much? Plus 5. So Br acts as both oxidizing as well as reducing agent over here. I have already given you example in what you see redox reaction. Yes. Now we are going to balance by what to say ion electron exchange methods. What to see 4A oxidation half. Oxidation half. So what we have 0 to plus 5. Yes. So we have to balance at first. What you see ionic state. Br2 K plus OH according to first rule. K plus Br minus K plus bromate plus H2. Yes. So we have to ionic state. So in ionic state what you see 0 minus 1 plus 5. Yes. So oxidation half what you see bromine to bromate. So what we have bromine to bromate. To Br2 at first we have to balance central atom 2 Br2 in this 1. So what we have to do? We have to multiply by 2 bromate. Yes. So now how many oxygen over here? 2 3s are 6. So 6 oxygen, in this case no oxygen. So I have already told you in a alkaline condition, for one oxygen atom we have to add 2 OH. So how many? 6. So hot 3 12 OH minus. Yes. And another side what you get? H2O. How much H2O? 6 H2O. Yes. So look at, so 12 hydrogen, in this case 12 hydrogen, oxygen is 6 12, in this case 12 oxygen, 2 bromine already balanced. So that is the chemical equation 1. So atom wise balance. Now we have to balance by charge wise. So 12 OH negative charge, in this case 2. So what we have to do? We have to add 10 electron. Why? So 12 OH have a 12 negative charge, 2 negative charge. So we have to add 10. So what you see? Neutral, charge wise neutral you can say. Yes. B, reduction half. Reduction half, what we have? What to say? Br2 again, bromide. Yes. So at first we have to balance atom wise, 2 bromine, 1 bromine. So what we have to do? That is the bromide. That is bromide. That is bromine molecule. Yes. So at first we have to balance by what to say? Atom wise, 2 bromine, 2 bromine. Yes. Negative charge 2. So what we have to do? 2 electron. Always we have to see electron must be anti to each other. So 2 electron over here, 10 electrons. So that is the second chemical equation. Now we have to cancel the electron. So what we have to do? We have to multiply by 5. 5 to the 10. 10. Yes. Then getting the net equation, how much we have? 12 OH. So what to say? 12 OH minus plus bromine. Next one is bromine 2 multiply by 5. 5 Br2. Yes. So left hand side. Right hand side, look at over here. 2 bromate. 2 bromate plus 6 H2O. Yes, plus 6 H2O. In right side, what is it? 5 to the 10 bromide. Yes, that is the. So at first, look at 12 OH minus. In this case, Br2. So what you see? 12 OH minus plus 5 and 1, 6 bromine. Right hand side, bromate. 6 H2O plus what you see? 10 bromide. Yes. So you can take 2 common over here. So what you get? 5 OH minus plus 3 Br2. Right hand side, what you see? Bromate plus 3 H2O plus 5 bromide. Yes. So to get, that is the net reaction, or you can say net reaction. To get the original equation, to get original equation we have. So what we have? So how many OH? 5. So what you see? 5 molecule of potassium hydroxide. Yes, 3 Br2. So what you see? 3. Yes, 3 left hand side, right hand side. So how many bromide? 1. So what you see? Potassium bromate. Yes, what to say, how many bromide? 5. Potassium bromide plus how much? 3H2O. So balance. Chemical equation. Yes. So I think we have clear in acidic medium how to balance, in basic medium how to balance. So for this always we have to know the 6 rules. If you know 6 rules, we have never problem. So thank you for waiting. Thank you for watching this interesting, what to say, video. So I think you have already done subscribe, and also convey your friends channel for learning. Yes. So have a nice day. So good, be happy, be healthy. So that is always good slogan. And next day I will come with next slide. Yes.